My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 575. In this lecture, I will continue my discussion on Adagrad. Before understanding this lecture, try to recall my previous lecture, that is lecture number 574. What is T here? T is basically means iteration number. As iteration number increases, your alpha t also increases. When alpha t minus 1 increases, eta dash t reduces. The reason being that when alpha t minus increases, under root of alpha t minus 1 plus epsilon also increases, because your epsilon is a constant, your alpha t minus 1 is a constant. When this whole thing means under root of alpha t minus 1 plus epsilon increases, this eta dash t, what happens for eta dash t? Eta dash t decreases, which means as your iteration number increases, your learning rate is reducing automatically or adaptively. This is the fun part. As your iteration number is increasing, your learning rate for that weight is adaptively reducing. This is the fun part, which means, remember, in our optimization chapter, we discussed that. Just try to recall our optimization chapter. In that we discussed that this eta is learning rate needs to be reduced. Let's assume for first iteration your eta equal to 0.01. For second iteration eta equal to 0.009. For the third iteration we will reduce it slightly. Let me say eta equal to 0.08. This is iteration based decay. We are reducing it constantly. Here what is the difference between eta equal 0.01 and 0.09? The difference, what is the here the value, but we are reducing it constantly. Here the value is for first iteration 0.01. Here the value for second iteration 0.009. Which means, what is the difference? The difference is 0.001. What is the difference between 0.09 and 0.08? The difference is again 0.001. So for every iteration we are reducing it by constant. In the case of Adagrad, my learning rate is automatically changes, adaptively changes based on previous gradients. Again, it does not just reduce as it wishes, it uses all the information in the previous gradients. What are the previous gradients? G1, G2, G3, so on, GT minus 1, isn't GT minus 1, comma GT. It is using all of the information in the previous gradients to reduce adaptively as iteration number increases. Let's look at the advantages and disadvantages. The major advantage here is you don't have to, no need of manually tuning your eta, isn't it? No need of manually tuning your eta for each iteration. Remember, for each weight you have one eta dash t, isn't it? For each weight, for each time or iteration, and if you have sparse features, some features may some sparse features and some dense features in your data, Adagrad automatically takes care of what is the right learning rate, because you are using previous grading, you are using previous gradients for that weight, isn't it? Not for all weights. There is one major disadvantage. Your alpha t minus 1 can become, very large as t increases, isn't it? What is my alpha t minus 1? Alpha t minus 1 is summation I equal to 1 to t minus 1 gi square, sum of squares of all sum of squares of gi squares, sum of this sum of squares of gi square, it is always positive, isn't it? This alpha t minus 1 is always positive. As t increases, your alpha t minus 1 increases. It could increase so large, it could become so large. What is my eta dash t? Eta by under root of alpha t minus 1 plus epsilon. Your alpha t minus 1 could become very large, isn't it, as t increases. That's what we are saying. So that eta dash t, so yeah, as alpha t minus increases, your eta dash t very small with each iteration. As eta dash t becomes very small, your what is the equation here? As your alpha t minus 1 is increasing, your eta dash t reducing. Eta dash t is very small. What is the update equation? Wt equal to Wt minus 1 eta dash t into g of t. In that case, what is happening here? When eta dash t becomes very small, this eta dash t into gt, it is close to 0. Let's say I am here. Let me assume we are at w t minus 1. Then I will not make any big movement, isn't it? I will not go from one point. Let me say it is w t minus 1. I am going from w t minus 1 towards w t. My step size, the amount of movement, my w star could be, let me say, here is w star. Just see, here it is. W star is here. I am moving from Wt minus 1 to Wt. After this, what's happening here? As this part is very small, your eta dash t is very small value. If it is very small, you can move from one weight to other weight from Wt minus, like that. You have to move from one weight to other weight. As this eta dash t is very small, this eta dash t is very small, therefore this step size is very small step sizes, isn't it? Means you may move Wt minus 2 to Wt, your optimal value, let me say w star, isn't it? I am moving very slowly from Wt to w star, isn't it? So that it could lead, this could lead to slower convergence, isn't it? This is the biggest problem. Slower convergence is it could lead to slower convergence. It will take much longer time to converge because the size of your step towards w star becomes very small. Yes, here your step size could be very small. Here, this portion from moving to Wt to w star, the step size is very small. Therefore, you will get slower convergence. Why it is very small? Why? Because this eta dash t becomes very small. If eta dash t is very small, means this difference between Wt to Wt minus is very small. The step size is very small. Therefore, you will come across a problem, slower convergence. It could lead to slower convergence. It will take much longer time to converge because the size of your step towards w star become very small. So Adagrad has nice feature. It has got advantages. What are the advantages it has? It has got the advantages. No need of no, just try to recall. So Adagrad has the nice features that no more headache of manually tuning learning rate. It works very well for sparse and dense features, but this has problem of, what is the problem here? Problem of slow convergence, isn't it? This problem of slow convergence, we will fix this problem in our next lecture, that is in lecture number 576 on ADA delta and RMS prop. Thank you very much.